Hello, Aaron. Thank you for sending me the email with the video and the timestamp on in which I did a multiplication problem somewhat mentally, but also with a verbal component. The problem was 28 sum 17, and you asked me, and in the video I said, if you want to know how this works, just, if you want to know how I did it, just send me a message, and I'll let you know. And here we are because you asked me. As part of this video, I want to quickly review the problem that we had done there. So let's go into here, and I think I got it right on the spot. So let's just take a look at this real quick. And I shouldn't have second guessed myself, but I try to be a little humble when I'm doing some of these videos. It did end up being correct, as you can verify easily with the calculator. So what I want to do first is I want to go through what I said while I was calculating this, and at the same time, illustrate it here on this whiteboard. So we're going to go back and forth between the two, and I'll pause it every time I say something and write something down. Let's start right there. It ends in a 6. Well, how did I know that? Well, because I know the basic algorithm for multiplying two numbers in general. For example, if I were doing this the standard way, it would be 28 times 17. And the first thing you would do is multiply 8 times 7 and write 56, or get 56 and write the 6 and carry the 5. Now, obviously, I didn't write all this down, but I'm familiar enough with how to multiply two-digit numbers to know that when written horizontally, the first thing that I do is I multiply these two numbers. And that 6 is going to end up being part of the answer, because when I get to the next part of the multiplication, there's either a blank or a 0 right here, which isn't going to change the value of the number above it. So by saying it ends in a 6, what I did is I multiplied the last numbers, the last digits in each number. 8 times 7 is 56, and I wrote down the 6, and now I have to mentally carry the 5. So let's see what happens next. Five and 14 and 8. Now, where did all that come from? 5 and 14 and 8. Well, in terms of the multiplication algorithm on the left side, the next thing I would do, and when I say multiplication algorithm on the left side, I'm talking about the part that I'm currently highlighting in yellow, and I'll keep it in yellow to make it easier to see. After I did 8 times 7 is 56, write the 6, carry the 5, the next move that I would do is I would multiply this 2 times 7 to get 14, and then I would add the 5. Now, I can go ahead and do that, but what's really happening here is that we have 20 times 7 is 140. And so that 14 is basically a couple of spots over. It doesn't take the place of, it's not over the 6 because the 0 in the ones place of 20 times 7. So I can ignore the 0 and just say 2 times 7 is 14. But I also said 5 plus 14 plus 8. Now, where did the 8 come from? Well, let's go through this multiplication algorithm real quick and do what we would normally do. Right here, we would do 2 times 7 is 14, and then we would add the 5. 14 plus 5 is 19. But then the next thing I would do is either put a placeholder of 0 underneath the 6 or just leave it blank. But the next thing I would do is 8 times 1 and put the 8 here. Well, the 19 came from the 14 plus 5. And of course, the 8 is the next thing I would add to it. So that's where I got the 5, the 14, and the 8. Now, let's go ahead and put that back in there. Now, as far as in the horizontal version of the problem to the left of the yellow box, where these numbers come from are, come on, draw. Why is it drawing in white? 2 times 7 and 8 times 1. Now, remembering that I had a 5 that I carried over from the 8 times 7 is 56, write down the 6, carry the 5. The next thing I did is I figured out, I got the 5, I got the 14, I got the 8, and then I had to add all those together. Let's go back to the video and see what happened there. Let's go back a few seconds. And at that point, what I was doing was I was carrying the 5 over from the 56. I did 2 times 7 to get 14. I did 8 times 1 to get 8. Hence 5 plus 14 plus 8. And you heard me call out the addition problem that I'm doing. Normally when I'm doing this, I'm not calling things out. Well, although even if I'm by myself, if I call them out when I hear the things, it makes it easier for me to process them than if I just think them. I'm using multiple sensory inputs if I'm speaking and hearing instead of just thinking, so more parts of my brain are working. But 5 plus 14 is 29, plus 8 is 5 plus 14 is 19, plus 8 is 27. And when I get that 27, one second. When I get that 27, let's think about how that plays out in the multiplication algorithm. The 27 over here in the yellow part is the sum of these, but only the 7 would get written and the 2 would be carried. I'll bring the 6 down here. And the 2 would get carried. So where's the 2 in this problem? Where's the 2 that I'm carrying? 9 plus 8 is 17, carry the 1, so I carry 1 up there. And so here's the 2 from the 27. And then the last part of the multiplication algorithm, come back yellow. The last part of the multiplication algorithm would be this 2 times 1, which would put a 2 right here. Excuse me, not there. Put a 2 right there. And then 1 plus 1 plus 2 is 4. But really, I just have to keep track of all the numbers I have to add over there. The trick to doing mental math is to not do the algorithms that are normally taught, because the algorithms that are normally taught, the thing in yellow, if you will, are structured so that you can kind of work the problem from left to right and write down all the intermediate steps, and at the end merge everything together. In this case, on the yellow part, we would do 28 times 7 to get 196. We do 28 times 1 to get the 28 moved over a space or with a 0 after the 8. And then we would add all those results. But the problem with trying to do that mentally is that you're keeping track of a lot of intermediate results. And at the end, you're trying to add those intermediate results. And that's a lot to keep track of. The trick to doing math mentally is to figure something out, write it down, and forget it, and move to the next thing. So the trick to this one, to doing 28 times 17, and I'm going to replicate it all over here, is to basically do FOIL. Wait, FOIL? FOIL is when you do something like x plus 2 times x plus 7. First, outside, inside, last. But if you notice these things that I'm drawing, I'm about to draw again. It is a FOIL problem because you could think of 28 as 20 plus 8. And 17 is 10 plus 7. And the advantage of writing them down in terms of the digits and place values, like the 2 and 28 means 20, is that every time you do a multiplication problem, there's a predictable number of zeros. When I do 8 times 7, there's no zeros at the end of that, unless I do something like 2 times 5. When I do the last part of FOIL. When I do the outside and the inside, both of those end in 1 0. And so they're all going to line up in terms of addition. And when I do the first part, it ends in 2 zeros. So I think it's easier to go from right to left instead of left to right, because you have to account for the carries, the extras that when you do the multiplying, you have to bring over to the next place value. So in short, here's how it goes. You do the last part of FOIL, write down the ones place, carry the tens place. 8 times 7 is 56, carry the 5. Now I'm going to write the 5 here, although mentally I would just carry it over or literally hold up fingers. Then you do the outside and inside parts of FOIL, add those results with the carry. So we get the 5, 2 times 7 is 14. Add the 5 to get 19. And then 8 times 1 is 8. 19 plus 8 is 27. Write down the 7, carry the 2, and the 2 gets added to, you know what? I don't want to put the 5 there. The 2 gets added to the first product. 2 times 1 is 2 plus 2 is 4. Now, I could have just said do these steps and that's it, but I want to show you the method behind the madness. I'm going to set up one more problem, go through it, and then I'm going to do one more, ask you to pause the video, see if you can do it, and then I'll do it as well. It takes a little getting used to, but if you can add mentally up to 3 values that are no larger than 2 digits, then you can actually do this pretty quickly and impress your friends. It's really just a parlor trick, if you will. For example, let's say I did, I don't know, 39 times 84. Make the numbers a little bit juicier. Then the flow would go something like this. Now, of course, if you're doing this mentally, you're not drawing these little rainbow pieces. You start by doing the last part of FOIL. 9 times 4 is 36. Write the 6, carry the 3. So I'm going to hold the 3 here in my fingers. Then you do the outer and inner part of FOIL. 3 times 4 is 12. Let's go ahead and add the 3 to that. 12 and 3 is 15. Now I don't have to worry about that anymore. 15, you want to remember one number at a time. Where was I? Oh, yeah. Let me retrace my steps. 9 times 4 is 36. Write the 6, carry the 3. 3 times 4 is 12, plus the 3 is 15. So now I'm remembering 15. 9 times 8 is 72. 72 plus 15 is 87. Write the 7, carry the 8. Now I can't hold up 8 fingers, so I would be doing this because I'm not actually writing things. I've got the 8, and then do the first part of FOIL. 7 times, where do I get 7 from? 3 times 8 is 24. 24 plus 8 is 32. So it should be 3276, and we'll verify that real quick. I'm going to open up a calculator, do a screen share with you. What was the problem we did? I don't remember what problem we did. We did 39 times 84. All right, let's take a look at the calculator. 39 times 84, 3276. I believe that's what I got. Yep. And that's how you multiply 2 two-digit numbers mentally. And again, the trick to doing any math problem mentally is to not normally do the traditional algorithm that you're taught in school, where you can write things down and don't have to remember them. It's to figure something out, write something down so you don't have to remember it. And you really only want to drag around one extra number at a time and then do something to make a new number. Otherwise, you got too much information to keep up with. I'm going to pose one I'd like for you to try. I'll take the numbers down a little bit. Let's say 62 times, let's do 23. Actually, let's make that 28, 29, because I want there to be a carry on the first part. So if you want to, pause the video, see if you can come up with this product mentally. And I should mention that there are a lot of other tricks depending upon certain types of multiplication problems, but this is a general problem, general approach that will work for any 2-digit by 2-digit number. So go ahead and pause the video, give it a try. Now, if you didn't pause the video, spoiler alert, here it comes. I'm going to do it just by writing down the answer and calling out numbers. I'm not going to write all the rainbows and everything. All right, so starting with the last, 2 times 9 is 18. Write the 8, carry the 1. I'm holding 1 here. Now I got to do outside and inside. Outside, 6 times 9 is 54, plus 1 is 55. Now I just got to remember 55. The inside is 2 times 2 is 4. 55 plus 4 is 59. Write the 9, carry the 5. I'm carrying the 5 here. And then the first part of FOIL is 6 times 12. 6 times 2 is 12, plus the 5 is 17. Should be 1798. Let's check it in a calculator real quick. 62 times 29. 1798. And we got 1798. There is a way to modify this for multiplying larger numbers, just to illustrate it to you. And I want to see if you can figure out what I'm doing here. I'm not going to go through all the details, but if I wanted to do, say, a 3-digit number times a 3-digit number, it is a lot more convoluted. we'll say 425 times, we'll say 733. All right, I'm going to call out the moves as I do them. I invite you to rewatch the video and see if you can figure out what I did. All right, so 5 times 3 is 15. Write the 5, carry the 1. I'm starting out like 2-digit numbers. All right, I got to do 2 times 3 and 5. You know what? I'm going to change it real quick because the fact that both of these digits are 3 is going to make it a little bit trickier to follow. So I'm going to change this. We'll make it 13. And then I'll start it over again. So what I've said so far is still the case. 5 times 3 is 15. Write the 5, carry the 1. Okay. 2 times 3 and 5 times 1. 2 times 3 and 5 times 1. 2 times 3 is 6, plus the 1 is 7. I got a 7. 5 times 1 is 5. 7 plus 5 is 12. Write the 2, carry the 1. All right, here's where it gets tricky. Now I got to do, here's the 1. 4 times 3, 2 times 1, 5 times 7. 4 times 3, 2 times 1, 5 times 7. And I still got the 1. All right, 4 times 3 is 12, plus 1 is 13. 2 times 1 is 2. 13 plus 2 is 15. 5 times 7 is 35. 15 plus 35 is 50. Write the 0, carry the 5. Now I have to do 4 times 1 and 2 times 7. I carried a 5. Luckily, I remembered I just said 50 because I wasn't holding up 5 fingers. All right, 4 times 1 is 4, plus 5 is 9. So now I got a 9. And then 2 times 7 is 14. 9 and 14 is 23. Write the 3, carry the 2. And lastly, 4 times, carry the 2. 4 times 7 is 28, plus 2 is 30. So it should be 303,025. 425 times 713. 425 times 713. 303,025. This technique is adaptable to as large as the number as you want. The problem is keeping track of where you are in terms of the products that you're adding. Once you go beyond 3 digits by 3 digits, it becomes a little bit tricky. It is all just based on standard multiplication algorithm, meaning when I do something like 425 times 713, the whole technique is basically based on what do I add here? What did I multiply to get the stuff that I add here? What do I multiply to get the stuff that I add here? And then you're just figuring out this 1 digit at a time in the sum and moving from right to left. To pat myself on the back a little bit, this is a technique that I developed on my own. I'm sure I'm not the first person who figured it out. But when I was learning to multiply in elementary school, I was like, well, I wonder if I can do this problem in my head, because I always like doing math fast. And so I tried to find a more efficient way to do the multiplication where I didn't have to remember so much. And so I was like, well, let me just figure out what I got to figure out to write down the first digit in the answer, and then the second digit and the third digit, and then came up with this technique. So it's pretty neat. But like I said, it's not something that I could say nobody's figured this out first except me. I'm sure many people way smarter than I figured out how to do this. All right, so I hope this kind of answered your question. It may have gone a little bit overboard, but that's just the way I roll.